This is Student Notes 1.11, Variations, and hopefully you remember some of this from last year, and if not, then here we go. So this first one is direct variations, y equals kx, where y is proportional to x, and if you notice, this represents a linear equation. And in this linear equation, your x, or as x is increasing, so is your y. And we actually can have both of these decreasing. Most of the time, you will see them both increasing. The main thing that you do need to know is that there's going to be a proportional relationship between them, okay? Just like it says here. Okay, on my next one, my inverse variation, same variables here, but y is equal to k over x. It says that y is inversely proportional to x. On this one, this actually represents a rational function, and this is the parent function. As x is increasing, your y is going to be decreasing on this. Okay, on joint variation, we have another constant here, or another variable, I guess you could say. We've got a z is equal to kxy, and so z is jointly proportional to x and to y. So what I would say here is that x varies directly to z, and I would also say that y varies directly to z. But x and y together have an inverse variation. Right here, it does mention the variable k. K is called the constant of proportionality, and you're going to hear that through basically every problem, and we're going to be using k all the time. All right, let's see what the first problem holds. During a thunderstorm, you see lightning before you hear the thunder, because light travels much faster than sound. The distance between you and thunderstorm varies directly as the time interval between the lightning and thunder. Okay, before I go any further, I'm going to go ahead and write down my varies directly equation, and that was y equals k times x. It says, suppose that the thunderstorm, or thunder from a storm 5,400 feet away takes 5 seconds longer than the lightning to reach you. Determine the constant of proportionality. This is the first thing I need to do. And write an equation for the variation. This would be the second part I need to do. Okay, let's go back up here and figure out what my varies directly equation is going to represent. I've written this first one, and so let's figure out what it didn't say anything about an x and a y, so let's figure out what we can replace. So it says the distance between you and the storm. So it looks like I'm going to replace this y with a d. I have to keep my constant of proportionality. And now what can I put my x? It says varies directly as the time interval between lightning and thunder. So it looks like I'm doing distance varies directly as time. Now this equation should look familiar. It looks like distance equals rate times time. So let's fill in what we know. Suppose the thunderstorm is, we've got our feet, away takes 5 seconds. This looks pretty straightforward. I'm going to put in my 5,400 for my distance, keep my constant of proportionality, and plug in my 5 seconds. Okay, that's a times. Now just solving for k, just dividing by 5, it looks like I get 1,080. And that is part 1. For part 2, it says write an equation. I'm going to bring my d equals kt, and all I need to do is plug in my k. And that is your part 2. On part B, it says, what does the constant of proportionality represent? Remember, this is asking what this represents right here. When I was looking at this, and D equals RT came into mind. If I solved for K, that would be D over T, which represents like a rate, right? Or a speed. So in our problem, what represents a rate or a speed? Speed of sound. So that would be the thunder that we're talking about. But the speed of sound is not exactly this. It actually is 1,126 feet per second. And we are talking about feet per second. So we're not exactly on. So how about we say close to the speed of sound, because we're not exactly right on. Okay? Okay, in part C, it says if the time interval between lightning and thunder is now 8 seconds, how far away is the thunderstorm? Okay, so we have a simplified version. We did it up in part A. We have D equals 1,080 times T, and now we just need to plug in the 8. These are pretty straightforward. So D equals 1,080 times my 8. And you can use your calculator since this is a word problem. So my distance is now 8,640 feet. And make sure you put your units. I will be checking for those. Let's move on to number 2. Oh, we're throwing in some science here. So Boyle's law states that when a sample of gas is compressed at a constant temperature, the pressure of gas is inversely proportional to the volume of gas. Okay, so inversely proportional. So I'm going to go ahead and write down that y is equal to k over x. That's my inverse. Suppose a pressure of sample of air that occurs at 0.106 cubic meters of 25 degrees Celsius is 50 kPa, so kilopascals. Find the constant of proportionality. So again, we need to find our k and write an equation that expresses the inverse. Okay, so we still got our 2 parts here. So let's figure out what y and x is. It says the pressure of gas is inverse proportional. So how about we put in a P to represent our y. We still have our constant of proportionality to the volume of the gas. So this is going to be V. Okay, one thing that we need to go back up here and look at, it says gas is compressed at a constant temperature, and they gave us our temperature right here at 25 degrees Celsius. Since our temperature is not changing, we are not going to do anything with that temperature. It's not changing at all, so we can actually ignore the constant temperature there. Okay, we're not going to plug that in. Okay, so our pressure we know is 50 kPas, and our volume is cubic meters right here. So that's going to give us 50 equals, K over the 0.106, and I've got to multiply to solve for K, so K is 5.3. That's our constant of proportionality. That's the first part. Second part, just got to find our equation, so that's just plugging it back in. So P is equal to 5.3 over our volume. So if the sample expands to a volume of 0.3 cubic meters, find the new pressure. Now, always make sure that your units are the same in case you need to change to make sure that they are exactly the same. And they are cubic meters, cubic meters. So bringing my formula down, this gives me P equals 5.3 over 0.3. And this is going to simplify to give me 17 point, and it's a repeating decimal, so I'm just going to round to 3 places. So this is going to be 667 kPas. All right, last problem. So Newton's law of gravitation says that two objects with masses m1 and m2, or m sub 1 and m sub 2, attract each other with a force that is jointly proportional, knew we would get to this, to their masses and inversely proportional to their square of the distance, which is r, between the objects. Express the law as an equation. Okay, so I'm going to write down what we know so far. This is what we were given for a joint equation or a joint variation. So let's see what we can plug in. We were given some things here that they want us to use for mass, and they told us to use this for force. So it says, attract each other with a force that is jointly proportional. So I would think that we're going to use F equals, we need to use our K, that is jointly proportional to their masses. So X1 or X and Y is going to be the masses, which is m sub 1 and m sub 2. Now, what is different about this one is it says and inversely. Remember, inversely is a division problem. And inversely proportional to the square of their distance, which is represented by just plain Jane R. So I'm going to square R. It says express this as an equation, which we have done. Use the traditional notation G for gravitational constant of proportionality. So this is the only thing that I haven't done. My constant of proportionality is really going to be K. So I'm just going to replace that. So this is going to be G times my masses over my distance between the objects, which is R. So this is the first thing that this is really all they're asking you. Okay? Now, I'm going to ask you a couple of things. What happens if you double one of your masses? Okay? You take one of your masses and you double it in your equation. What happens to the entire equation? So basically, what happens to your force? Okay? And if you're not sure, you can plug this in. So here's your force. Here's your G, and you could double one of your masses, or mass sub 1. You've got your mass sub 2, and you divide it by your R squared. What would happen to that force? Well, I would hope that you know this. That means that your force is going to double. One more question. What happens if, let's do something totally different. What happens if this is doubled? Your distance between objects. If R squared is doubled. Is it going to be exactly the same thing? And I'm just trying to change it up here. So, force equals your G times your mass, 1. Well, I didn't need parentheses there. That's okay. Your masses. Now, remember, when you're squaring this, or when you're doubling this, you're actually putting it in parentheses. So, are you doing it times 2? This 2 is actually raised, so hopefully you thought about that. So if your 2 is raised there, then it's actually 4. So your force is quadrupled. Okay, so there's just some things that might help you out on your homework. Okay,